All right, so we are now going to be talking about solution concentration in our notes. You're going to need your reference tables. So we're going to be using table T because we're going to be doing some calculations. And you actually might need your periodic table because we might be looking at a review of moles and gram formula mass. All right, so let me get my slideshow going here. Alrighty, from our current slide here. All right, I want to go into this. All right, and let me hide that over there. And where is it? Okay. And we'll move that up there. All right, solution concentration. What is it? All right, so we know what a solution is, right? When we have a solute dissolved in a solvent. So when we have solution concentration, we have dilute, right? So that's going to be a new vocabulary word. So solution where very little solute is dissolved. And we're going to call that unsaturated. Dilute means weak and watery. All right, so let's kind of call that kind of like a weak tasting solution. If we were talking about the taste of something, I like to talk about Kool-Aid when we talk about solution, right? So a dilute solution concentration of Kool-Aid would be a very weak Kool-Aid, right? Just a little bit of that solute, which would be Kool-Aid, dissolved in quite a lot of water. And then obviously in chemistry, we don't taste solutions of like hydrochloric acid or, you know, other stuff like that. All right, so it tastes watered down and weak. And so now we have the word concentrated, which is kind of like strong solution. So too much solute, right? So that means a lot of solute is dissolved in the water or whatever solvent that we're using. So if we're talking about our Kool-Aid, right, or sugar, it's going to be too sweet, too sour, too bitter, right? If we have a lot of lemon and lemonade, right, it's a very concentrated lemon. Maybe you've heard of juice concentrate, which you can buy in the freezer section of the grocery store, right? You can buy orange juice concentrate, lemonade concentrate, fruit punch, all different kinds of concentrates. It just comes in like a little can. You open it up, put it in a pitcher, add some water, and then now you have, you can adjust how much water you want to add based on what you'd like it to taste like. If you like it very dilute, right, very water, kind of like that watered down flavor, or weak, not a lot of flavor. And some people like that, that's okay. Taste is individual. Or maybe you like it like super, super sugary and really like strong tasting. And then you would have a more concentrated solution. And so now we need to have a way of expressing these concentrations beyond just that vague dilute or concentrated. And in chemistry, we're going to use molarity. Yes, and your fears are correct. The mole is coming back. It obviously has something to do with the mole. And so molarity is the number of moles of solute, right? Again, that's the substance that's being dissolved in liters of solution. Notice how it says liters of solution, not liters of water. Okay, so because the volume is going to be adjusted. If I put some sugar in the bottom of a glass and then I add water to it, right? So that sugar and water is the solution, and that total volume is what we call the liters of solution. Because that volume of the original solute, like the sugar in my example, occupies space. Even though it gets dissolved in the water, it still contributes to the volume. And so now we have on our formula on table T, we have a formula for molarity. So molarity is equal to the moles of the solute, right? That's the substance being dissolved, divided by the liters of solution, and making sure that it is liters and making sure we do not use milliliters. In the beginning of the year, we did our metric conversions. And so let me just do a quick review. I have 1,000 milliliters is equal to 1 liter. How do I know milli is 1,000? On the front of your reference tables, table D, I believe, it says 10 to the minus 3 for milli. That means it's a factor of 1,000. And so that means if I have milliliters, right? So let's say I have 1,000 milliliters and I want to go to liters. I need to divide that by 1,000 or move the decimal place 3 places to the left. That's 0.1 liter. Okay, so keep that in mind. All right, the units, moles per liter, right? That's the unit for molarity. And then that is being our capital letter M for molarity means moles per liter, right? Capital letter M. So I'm just going to write down over here, if I have, let's say, a 0.2 molar solution, and I'm going to say versus a 2 molar solution, one is concentrated and one is dilute. So which one is concentrated and which one is dilute? Right, dilute means weak. 0.2 is smaller than a 2. So then we're going to call this dilute, and then we're going to call this one concentrated. So now let's work on how do we do these calculations. All right, so I have a 2 liters of solution contains 53 grams of sodium carbonate. Calculate the molar concentration. So we need to calculate the molarity. All right, molarity is equal to moles over liters. So now, first of all, moles is not grams. Moles and grams are related to each other through the gram formula mass. Remember our mole calculation on table T, right? Moles is equal to given grams, I just use G for grams, divided by that gram formula mass. All right, so this is connecting us back to our formulas, math of formulas unit where we had to calculate the gram formula mass. So to calculate the gram formula mass, this is that where this 106 comes from. Where does that 106 come from? I have 2 sodiums. I have to take the mass of 2 sodiums plus the mass of 1 carbon plus the mass of 3 oxygens. So I have 2 sodiums, each with a mass of 23. And now I'm going to add the mass of 1 carbon with a mass of 12. You don't have to multiply by 1, but I just like to show it as I'm drawing. And then I have 3 oxygens, each with a mass of 16. Where do I get all of these masses, right? You get these masses from the periodic table, right? In the upper left-hand corner of every element is the mass of the element. And so this is where that 106, and that means grams per mole, right? Because that's what moles are, right? So that means that's where that 106 comes from. And so now to get the moles, right, I have to do grams divided by gram formula mass. Because if you're given grams, I can't work with grams in this formula. I have to convert this to moles. So then I'm going to take, that's 0.5 moles, right, when I divide those two. So now I'm going to take my molarity, that's what I'm looking for, right, because it says calculate, this is my X, this is what I'm looking for. Now I have the moles because I just converted the moles to grams, right? So let me just write that out. So convert grams to moles. And I'm just going to write, say, using our gram formula mass, just so that you have that written down. All right, so I have to find, where's my liters of solution? Right here, there it is, liters of solution. All right, so I have my 0.5 divided by 2. That's going to be a 0.25 molar solution, okay? And we're going to do some practice with this in your notes. So now let's say here we have a sugar solution. So what mass? So then basically is saying I need to end up with mass, okay? Is needed to make 325 milliliters of a 0.258 molar solution. Now let's see, what do we need to do here? All right, I need to convert the milliliters to liters because I know when I'm using this capital letter M that I have that molarity equals moles over liters of solution. So I know I'm going to have to convert that milliliters to liters, right? And again, milliliters to liters is a factor of 1,000, right? I need to divide by 1,000. I also need to figure out, in order to end up with this mass, I need to get to moles, right? Because if we're thinking about this capital letter M, right? Capital letter M is equal is my formula moles divided by the liters of solution. So if I have that capital letter M and I have an easy way to get to those liters, I need to get the moles before I can go get to those grams. And then I'm going to take the moles and then convert that to mass with the gram formula mass. All right, moles to liters, right? Calculate the moles using my molarity equals moles over liters formula. And then convert moles to mass using my moles is equal to given grams divided by the gram formula mass from table T. All right, that's our strategy. All right, first step, molarity equals moles over liters. So my molarity is equal to 0.258. How did I get that? That's right here in the question. 0.258, capital letter M for molarity. My liters, 0.325. Where did I get that? Well, that's how I converted 325 milli, right, liters, right? So if I have, it means 3 decimal places to the left because I divide by 1,000, somehow messed up my pen. Right, so I'm gonna go 1, 2, 3 hops to the left, divide by 1,000. Okay, so this is my liters, here's my molarity. So I take my 0.258 molar, right? Molarity is equal to moles, that's what I'm looking for, correct? Divided by my liters of solution, which was the 0.325. And so now that is going to be equal to 0.0839. And then I need to then multiply by 180 grams per mole, right? So I have, where did that 180 grams come from? Okay, 6 carbons, right? 6 carbons, each with a mass of 12, plus 12 hydrogens, each with a mass of 1. And then plus 6 oxygens, each one with a mass of 16. And then remember we have our moles is equal to, right, so how did I get that 0.839 times 180? All right, so let me just write that down over here. Okay, so I have my 0.0839, right? Because that is going to be our moles. And then I have moles converted to grams. 1 mole is 180 grams. Okay, so then I multiplied across. Remember, when you're given moles, you multiply. And of course, you can also just substitute it into your formula from table T, right? So I'd prefer dimensional analysis, but moles is equal to given grams divided by the gram formula mass. And so what do we have? We have the moles, 0.0839. And I'm looking for the grams divided by the gram formula mass of 180. And so then again, you are multiplying times 180. 3 different strategies, right? Given moles, you multiply by the gram formula mass. Dimensional analysis way, table T way. 3 ways to get the same 15.1 gram answer. All right, now what does this mean? Okay, yes, we can do all these calculations, but remember, chemistry is a lab science, so we need a way to take this into the lab. Okay, so when we prepare a solution in the lab, so it's basically the same thing as like cooking in the kitchen and making Kool-Aid. It's just going to be just a little bit more precise. So we need to measure out the mass of the solute. So let's say we're taking Kool-Aid. Let's make the mass of this Kool-Aid. And then I'm going to add the solvent to the final volume. Okay, so this doesn't mean, if I want to make a liter of Kool-Aid, I don't add the Kool-Aid to the pitcher and then add a liter of water, because that Kool-Aid occupies space, it has volume. If I want exactly 1 liter, I add the Kool-Aid to the pitcher and then I fill it up to the 1 liter mark on my pitcher. And then there we have it. And then we stir to mix or shake, put a stopper on if it just depends on what kind of vessel that you're making this dissolving in. Okay, so this is the important part here, is that we don't add the volume of water. We're adding the water up to the final volume. It's an important distinction, right? Because we want to make sure we have an accurate solution. All right, so that's going to wrap up. In our next video, obviously, we're going to talk about parts per million. But that's it for today. And make sure you practice those molarity calculations, because remember, these are going to be a lot of two-step problems, right? Moles, between using moles and molarity. All right, so in our